How's it going? This is Jake. We've been doing a bunch of Tone.js tutorials which use the Web Audio API. And sometimes you want to do things that don't make noise but interpret noise and visualize them. And so what we're going to be making today, quickly, hopefully, is a spectrogram, which basically visualizes. Let's see if we can get something here. Spectrogram, let's get an image, visualizes audio. So if you think of a bunch of vertical lines here going left to right, those are the frequency spectrum from low notes or low tones to high tones in hertz. The color is how loud they are. If you've seen kind of like an equalizer with all the bars bumping up and down, you're basically doing that rotated over time. And so you get a visual representation of your audio. And so we're going to build one of these for the microphone input. My microphone's right down here. And we can do all of that with the Web Audio API without using Tone.js or anything like that. So I think maybe the first thing we'll do here is get a canvas, and let's just say HTML body, height is 100%. You have to do that because they're parent elements of the canvas. And then our canvas will be display block, height 100%, width 100%. I think that's all we need there. Let's just background red and make sure it exists. Yeah, okay, so there's our canvas. This is what we're going to be drawing on. I'm going to save this really quick. So let's get rid of the nonsense here in the console. And so I'm going to grab that canvas before we forget about it. So const canvas equals document dot query selector canvas. And actually, I'm just going to do document dot body to be more specific. This is just like jQuery. If you've used jQuery, we have query selector now in vanilla JavaScript. So that will give us our canvas. So we can console.log canvas. And there she is. Okay, so what we're going to be drawing on is the canvas context. So to get that, we do canvas.get context 2 dimensions. So this is a specific context of the canvas. You can also do WebGL this way, but we're going to be drawing in 2 dimensions. And so we're getting the context of our canvas, and we're storing it there. The next thing we're going to need is the audio context. Well, first let's get the microphone. So to get the microphone, I think it's navigator.mediadevices.getUserMedia. Here we go. We're just guessing here. Audio, true. If we wanted to, we could also get the video. Same feed as my camera here. So media devices get user media audio true dot then, and we'll just pass in a function called process. Let's define process, and this is going to take our stream. So this is going to be an audio stream coming through. Let's just see if we got this right. Console.log stream. Boom, we got a stream. Okay, cool. So this is basically something that we can tap into whenever we want. And when we tap into it, whenever we want, we can get the current audio that's happening in the microphone. Notice how this is just called once. This process is called once. So we're going to end up using request animation frame, which is something that loops at the frame rate of the computer, to ask for the current audio data at that time. All right, so what we're going to need to work with here is the audio context. So I'm just going to say a context equals new audio context. Note, we're doing this for modern browsers only right now. You can do research on, if audio context isn't defined, you're going to need to use WebKit audio context and so on. We're not going to get into any of that right now. In fact, this is fairly new, so not all browsers will be able to do it this way. There's another way to access user media for older browsers, but we're not worried about that because we're just having fun. Let me see, what did I do over here? Let's get an analyzer. That's what we need. Analyzer equals atcx dot, what is it? Create analyzer. So our analyzer is we're gonna connect our stream to our analyzer, and then we will ask our analyzer for specific types of audio data. We can ask it for different types of audio data, but what we're interested in is the frequencies spectrum at that point in time. So let's see. We also, let me see here, const width is going to be cvs.width equals window.inner width. We're going to make this full width and full height. This is important because the canvas needs dimensions if we're going to draw on it. Right now the canvas has no dimensions. So we're saying the width is equal to the canvas width, which is equal to our window inner width. Let's just run this and take a peek. So if we inspect our canvas here, width is 668, height is 938. And that's because that's the size of our window here. Brilliant. All right, what else do we need to do? Oh, we're going to set a Fft size. So actx.fft size. Let's just set it to 1024 for now. This is basically how detailed we want our data to be. So this needs to be, I don't know the minimum, but this could be 1024, 512, 256. It could also be 2020 or 2048. So 256 is half of 512, which is half of 1024, which is half of 2048, and so on. In fact, let's just do, what is it? It's 4096. All right, so this is going to be super high resolution. We want to get as much data as we can. If you experience problems with this, like your computer's not fast enough, decrease this to like 1024 and you'll have no problems. Actually, 256. We're gonna keep it really small so that we can look at the data without it being massive. All right, so once we get the stream, we need to create a source. Source equals audio context dot, what is it? Create media stream source. And then we pass in the stream. So this will wrap, spell that right. This wraps our stream in a source object, which will allow us to connect the stream to our analyzer. So the next thing we do is we say source.connect analyzer. And then we need to look at the data. Let's see here. Const data equals new. Here we go. You ready for this? uint 8 array analyzer dot frequency bin count. All right, so this is garbage. I know. This is the only complicated part of this. Frequency bin count. So this is basically a number. It's the size of how much data we have. So we're creating an array that has a length of 1024. We can bump this back down to 256. And that's going to be our data. That's going to be an array of data, audio data. And so what we can do here is we're going to create a loop. So function loop, and then we're going to window.request animation frame on loop. So that'll call this again as soon as it has the FPS to do so. And then we need to get byte frequency data. So check this out. Analyzer, this is the last crazy web audio thing. Analyzer.get byte frequency data. And so what this will do, let me make sure this is accurate. What this will do is, using our data array that we created up here, the analyzer will populate it with the frequency information, how loud each frequency is. Notice that we're not storing this in something. We're not saying data equals this. It transforms the data array itself. So we can do for let I equals 0, I is less than, let's do this, const len equals data.length. This might be driving you crazy. All right, so we're getting our length of the array so that we don't need to calculate it again down here on every loop. I++. So what we're gonna do is we're gonna loop over our data array. So let's say let val equal data I. And I'm gonna kill request animation frame. I'm gonna save. And we're gonna console.log the value. So this is only going to run one time, okay? Because we killed request animation frame. So we're getting the user media, which is asking for permission. On your computer, it'll say, do you want to let CodePen access your microphone? And then you'll never have to answer that question again. That's why it didn't pop up on my screen. So we're getting access to the microphone. Then we are passing the microphone stream into this process function, which creates a media stream source from the stream, connects it to the audio context analyzer, which is the thing that can do a bunch of stuff and analyze stuff for us. And then we are creating an array to hold the analyzer's data. And then on every loop, we get frequency data. So there's multiple methods we can pass in here. We can get the waveforms data, but in our case, we want to get the frequency data, which is how loud the low is, how loud the high is, and every step in between. And then we loop over every item in the data from the analyzer, and we're just going to log it to look at those values. So let me do loop, we call it once, and since it doesn't call itself, we're fine. Gotta stop hitting Command S, and let's just run it. All right, so at the beginning, it's 0. At the beginning, everything is a value of 0. Let's, what happens if we set timeout loop? 1 second. So this will wait for a second. I'm gonna talk so we might get some data here. There we go. So each of these represent a value of 0 to 255. It's going to start at our lows. So on the very low end, we're at 0 5 times. So 0 value, 0 value. That refers to how loud our lows are. Then we get a 34, 44, all the way up. And so there should be 1024 of these. So let's go ahead, instead of logging, let's draw something. So I'm gonna remove this timeout. That was only there so that we got something the first time. Let's just do it. So what we need to know is the height of each item. So in here I'm gonna say const h. Remember, we have a height of the canvas, and then lowercase will be the height of, we're going to basically draw lines all the way up for each of these values. So what we need to do is we need to say the height is our main height divided by however many items we have. So if we have 10 items, each one will be 10% height. Sorry for the notification. So each one will be 10% of that if we had 10, but we have 1024, so each one will be 1/1024th height. So that's the height of an individual line segment that we're going to be drawing in our spectrogram. And do we need anything else? Yeah, let's draw it on the far right. So const x equals our width minus 1. So we're going to draw it all the way to the right-hand side here. All right, so in here, we have a value, and let's just call this a ratio now and divide it by 255. So that'll give us a 0:1 ratio for the volume, representing the loudness. So we have our ratio, so we'll do context. Remember our audio or our canvas context up here? This is where we start drawing to the canvas. Context.begin path, context move to x, that's going to be the same for both of these here. Move to x, and then the y value is going to be I times height. And then we are going to line to I times height plus height. So that will start at the top with our low end and go down to the bottom for our high end. We'll invert that in a second. And then we stroke. That'll draw our line. Stroke style equals. So now we're going to set the color of it. And let's just do HSL. That's going to be easy. HSLA. No. RGBA. 0, 0, 0. That'll be black. And then let's just plug in our ratio here. And then just for this, since we're going to be doing just one of these here, in our loop, we're going to ctx.clear rectangle x0, y0 width height. That'll clear it on every frame update. And then let's make our line width like 5 so that we can see it. All right, let's just see what happens here. Boom, 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 boom. You see it all the way over there? I'm going to make it a tiny bit bigger here. It's funny. In order to make this responsive, I'm going to have to talk into the microphone that you're hearing in this video. So pardon me talking really closely. All right, so those are all of our little lines. They look like they're horizontal because they have a very wide line width and a very short height. But there we go. This is what we're looking for. I'm going to remove our line width here because we want this to move left to right. Well, you can see our lows at the top. Let's put those at the bottom first. So that's going to be height minus, and this is going to be height minus. And this should get that inverted. So now our lows are all the way down there, and our highs are all the way up at the top. Cool. And then their opacity, the alpha channel of our RGBA, is the ratio of value, which is 0 to 255 divided by 255. So that'll be 0 to 1. Awesome. We're gonna change the color and stuff, but first let's start watching this move horizontally, because we're trying to create this, and we'll have this pan from side to side as time goes on. So Boom. I'm going to remove our line width. So that'll just be 1 now. So we'll hardly see it there in a corner. And the handy thing we can do here is before we clear our space, let's get image data. So what we want to do is for each frame, copy everything except the first pixel on the left. So that whole first column of pixels on the left. So we'll get everything except for that one, copy that image, move it over 1 pixel, then fill in the far right image. And if we do that over and over again, we're just going to end up getting this effect of going from left to right. So to do that, we use the canvas get image data on our context. And so we'll give an X value of 1 because we want it to be offset 1 pixel, a Y value of 0, and then the size that we want to capture of the image is going to be width minus 1, so the full width minus 1, and then the full height. Then we're going to clear the entire canvas, and then we can do put image data, let image data equal this, put image data, and we pass in the image data we just captured, and then we're going to say 0, 0 for X and Y, and it should do the rest for us. Let's see. All right, here we go. Cool. So this is looking a lot more like a spectrogram. If we look at this here, we're getting close. So this will just continue. When I do a low note, we get the little black down here, extra dark. That's pretty crazy. All right, so here's our spectrogram. This is great. Let's change the colors up a little bit. Instead of, let's just set the context.fill style to be HSL. I think we're going to go for the range of 280, which is like purple is our hue, so that's 0 to 360. Saturation will always be 100%, and our lightness, I think the minimum lightness, we're going to go with 10%. So then here, instead of clear rect, let's just do fill rect and see what this looks like. All right, so we have a deep purple, and then our lines are black. We're going to change that. What did I do here? We have our ratio. Let's let our hue, that's the thing that's going to change the most, equal so it's going to end up being 280 is our minimum, right? And then let's go up to yellow, which is 60. $280 plus 120. 280 plus 120. Sorry, I'm doing this on another screen. It's 400, which would be 40. So we're going to go up to 40. Sorry, this is confusing. So we want our ratio times the size of 120. So that's going to be a number from 0 to 120 plus 280. So when that ratio is 0, it's just going to be 280. When that value is 1, it's going to be 120. Everything in between is going to be a number between 0 and 120. Right? So that's this right here. Then we're going to add that to 280, but we need it to be modulo 360 so that when it goes over 360, it starts over from 0 and goes up to 40. That's confusing, but we're just going to run with it. So our hue will be that value. So that will be 280 through 360 to 40. That's what that hue is going to be. It's going to be on that range, and that's going to be close to these colors because yellow is at like 40 or 50 or 60 ish. The purple is 280. So we want it to go between those values. You can see it over here on this scale, right? So our saturation is always going to be 100%. And then our lightness is going to be, let's go 10% up to 80%. So to get that value, we are going to we're going to add 10. And if we want the max to be 80, we subtract the minimum, so 70. So 70 times rat. So that will give us a number that's between 10 and 80. And then down here, all we have to do is just say HSL, Q, sat, lightness. Let's see what this looks like. Oh, lightness needs to be a percentage. 70 times rat plus percent. What about this? There we go. Awesome. So this is pretty great. This is exactly what we're looking for. This looks very similar to this. All we have left to do here is get rid of that white at the very beginning. So we set the fill style, but let's just do this out the gate before we start copying image data and stuff. All right, let's look. Boo-doo-doo. That's close. I don't know if you can tell, but it's a little darker. That's probably just because we're getting very small values that are making it darker. All right, so this is our spectrogram. Hope this was insightful. Audio context is super powerful. Let's get a sense of whether or not this changed anything. This is driving me crazy. I don't know why. This looks like the same resolution. I don't know if this Fft size is actually doing anything. Is it doing anything? I don't think it's doing anything. What did I... Hold on. Fft. The analyzer.fft size. I'm stupid. There we go. So let's take a peek at what this value is now. Yeah. So it's half of the Fft size is what this is. That's what it's supposed to be. That's what I thought it was earlier. I was just doing audio context Fft size instead of analyzer Fft size. All right, so that just shows you nobody knows everything. Awesome. Well, hopefully this was helpful. Spectrogram, I'll put a link in the description to this if you want to take a peek at the code. And yeah. Awesome. See ya.